This video is on the molar volume of a gas at STP. So all that means is how much space does a gas take up if you're at STP. So remember STP first of all. STP means your standard temperature and pressure. STP, standard temperature and pressure, which standard temperature is 0 degrees Celsius or 273 Kelvin, and 1 atmosphere of pressure or 760 millimeters of mercury. So these problems are all at STP. So as you know from the past, a mole is this many particles, Avogadro's number of particles. That's molecules or atoms. A mole, you can add up the mass in the periodic table and say what the mass of a mole is. And then if you have a gas at STP, doesn't matter what gas it is, carbon dioxide, oxygen, a mixture of gases. But if you have 1 mole of a gas at STP, it takes up 22.4 liters of space. So this box, oops, this is the wrong box, but this is about the same thing. Okay? A mole of gas takes up about this much space. Okay? 1 mole of gas takes up about 22.4 liters of space, which is about this box right here. So that is true for any gas. So if you have 22.4 liters of gas, it is exactly a mole. So that means there's that many particles in there. Could be oxygen molecules, could be nitrogen. That's only true for a gas. A mole of water only takes up about this much space. Okay, it's only 18 milliliters because water molecules are way closer together. So here's a few problems with these. Pretty simple stuff. Just use low dimensional analysis. What is the mass? We're looking for grams of 1.5 liters of carbon dioxide. Again, we're at STP. If we're not at STP, we can't use this number because it's not true anymore. So we start with our 1.5 liters of carbon dioxide. We know liters needs to go down here, so our labels will cancel. So we're using this conversion. 22.4 liters is equal to a mole of carbon dioxide. So this is way less than a mole. It's not even close to 22.4 liters. We want to get to grams, so we got to do another step. A mole of CO2, again, labels cancel. Mole, mole. A mole of CO2 now to grams of CO2. Well, a mole of CO2 is 44 grams. Take a 1.5, dividing it by 22.4 to get into moles, times 44 grams. Answer there is about 2.95 grams. So if you have that many grams of CO2 at STP at 0 degrees Celsius, 1 atmosphere of pressure, it will take up only 1.5 liters. So one of our big graduate cylinders is a little bit more than that. This one's asking for volume. So whenever it's asking for volume, we're looking for liters. Okay, looking for liters in this case. So our answer needs to be in liters. Have this many molecules. Times 10 to the 22nd is less than a mole of molecules, so we're going to get an answer less than 22.4 liters, probably quite a bit less. That says 1.75. Sorry, you can't read that. So we got 1.75 times 10 to the 22nd molecules. I'm going to put an MC for molecules. So I know I need molecules here, always converting it into a mole. Well, a mole of molecules is Avogadro's number, 6.02 times 10 to the 23rd. So we divide that to get to moles. To get to liters, our 1 mole needs to go on the bottom because you have a mole right here. We're going to say 1 mole is 22.4 liters. Again, that's only true at STP, not true any other time. So we're dividing this to get moles. Again, that's going to be less than a mole. Multiplied by 22.4. Answer there is 0.65 liters. Again, not very many liters because not that many particles, really, less than a mole. Last one here. Again, asking for volume, so we're looking for liters. It's telling us how many moles we have. So just like in the past, whenever we start a problem with moles, we typically only need 1 step. There's our gas. Moles here, so we're going to say 1 mole down there. And a mole of any gas takes up 22.4 liters of space. That's all we got to do. Multiply 1.175 times 22.4. 3.9 liters. So pretty simple conversion problems.